Okay, guys, so this will be part 2 of rational equations. So we got question 1 and 2 done. Oh, I don't have my smartboard on properly. We got question 1 and 2 done, but this is question 3. We'll do question 4, and then we're probably going to do question 1b in the homework, just because it ends a little bit differently, and I wanted to talk about that. So for question 3 here, so we have rational equation. So 18 divided by x squared minus 3x equals 6 over x minus 3 minus 5 over x. So we said previously your first step needs to be factoring anything that can be factored. So I know that I can factor a common factor of x out of the first portion. Nothing else to be factored. So once I've factored it, I can see that the denominator of that first portion is actually the lowest common denominator. So our lowest common denominator is x multiplied by x minus 3, because that has a portion of every denominator in it. And so now, I guess I can get rid of that. Oops. So now I need to multiply each term by that lowest common denominator. I don't know that I'm going to be able to fit all this. Hopefully you can't hear all the chatter in the background. Okay, so let's get colors back so we can see what's going to actually cancel there. So this one, okay, we're getting rid of that denominator. This, just that x minus 3 is a common factor, and x is a common factor there. So what do we have left over? We have 18. We have 6 times x. And we have x minus 3 times 5. So that distributive property for that last portion. So 5 times x is 5x. Negative 3 times 5 is negative 15. Notice that I'm being very careful with this subtraction. I've left it in the brackets because, again, remember we're subtracting all of 5x minus 15. So 6x minus 5x. And now this is going to be plus 15. And so combining our like terms, I'm going to subtract 15 from both sides of the equation if I'm trying to solve for x. So 18 minus 15 is 3. 6x minus 5x is 1x. So I've actually, in this case, solved for x. So that's the value for x that makes the equation true. The other thing that I need to do is look at my non-permissible values for the equation. So it's kind of easiest to see after I factored that bottom, or before, I guess. So we have two non-permissible values. So we have a non-permissible value of x cannot be equal to 0, because that would make that denominator equal to 0. And we have a non-permissible value of x cannot be equal to 3. So now, hopefully you're panicking a little bit, because I'll bring that down here. X cannot be equal to 0. X cannot be equal to 3. But I'm saying x is equal to 3. So one of our restrictions is actually the answer to it. So since x cannot be equal to 3 is a restriction, we have what we would call an extraneous answer or an extraneous root. And we feel very sad face for that. So x minus 3 would make the equation true, but if you tried to verify that, your calculator would have a real tough time because you can't divide by 0 in those fractions. So needed to show you that one. It's not very inspiring. Okay, 2 more. Is this it? No, it's C. Okay, cool. We don't have it in the smart file. So we'll just ignore that. So question 4 is 3c over 4 minus c squared plus 1 over c minus 2 equals negative 4 over c plus 2. So this guy, again, factoring first if you can factor. And hopefully you can hear me yelling difference of squares factoring in your brain for this one, because 4 is a perfect square, c squared is a perfect square. So we would write that as 2 subtract c, 2 plus c. Nothing else I can factor at this point though. Okay, so now trying to determine our lowest common denominator, and there's a bit of a tricky part in this one as well, because so c plus 2 and 2 plus c is the same thing. So our lowest common denominator is going to have that c plus 2 or 2 plus c in there. But c minus 2 and 2 minus c, c minus 2 is not the same thing as 2 minus c, 2 subtract c. So what we can do is we can remove a factor of -1 from either of those, from one of those. And then what we would have, so if I remove a factor here of -1, sorry, I'll show you what I mean by that. So if I remove a factor of -1 from this, now I would have -2 plus c, which is c minus 2. So we've seen something like that before, that if you have a factor that looks almost the same, think about if you can remove a factor of -1 to make it the same. Okay, so now our lowest common denominator is c plus 2 times c minus 2 times -1. Okay, I'm not going to be able to fit that all on the smartboard, but what I can see is if I look at that factor, I'm going to get my colors out again. See if it'll work. So with that first one, it's going to cancel all 3 portions of it, right? Everything in your lowest common denominator is going to cancel out from there. So I'll have 3c. So with this next one, we're going to get rid of this c minus 2, but we'll have everything else still left. So it's plus 1 times c minus 2, sorry, that's c plus 2, and -1. And finally, the last one, I'll do it in green this time. So we'll get rid of the c plus 2, and what we'll be left with is -4 times c minus 2 times -1. Okay, so now it's starting to simplify that. So just make sure you're distributing everything through at each point. So 3c. So multiplying that -1 through here. I'm just going to kind of, oh, will it let me erase that other one because, well, 1 multiplied by anything is the same value. So -c minus 2. So I'm going to just kind of not skip a step, but -1 times -4 is going to be +4. And then I can use my distributive property through here. So 4c subtracting 2. So now combining all your c's on the same side, all your constants on the other side. So, I guess I could do 3c minus a c is 2c. So I'm going to subtract 2c from both sides, and I'm going to add 8 to both sides. So what we'll have, so negative 2 plus 8 is positive 6. 4c, subtract 2c, it's going to be 2c. Now dividing both sides by 2, c is equal to 3. So just checking with the non-permissible values. So we'd have a non-permissible value. We would actually have 3. No, we would actually only have 2 non-permissible values. It would be c cannot be equal to 2 or negative 2. So negative 2 here, positive 2 here. Works for both of those as well. So just 2 non-permissible values there. Okay, it doesn't conflict with our answer, so we don't have an extraneous answer there. So lastly, you'd want to verify this answer. So substituting in a value of 3 to the original equation anywhere you see a c. Let's see if I can do that. So 3 times c, again c is a 3, over 4 minus c squared, plus 1 over c minus 2, negative 4 over c plus 2. Okay, so again, we're, kicked it all the way off. So 3 times 3 is 9. 3 squared is 9, so 4 minus 9 is negative 5. 1 over 3 minus 2 is 1. And negative 4 over 5. So you could punch it into your calculator if you don't want to deal with the fractions. So 9 divided by negative 5 plus 1 is going to get you negative 0.8. And negative 4 divided by 5 is negative 0.8. Yay, much success. Okay, so I said that we're also going to, oh, sorry, we can, just the summary at the bottom there. Is this the same one or did I change it? To solve a rational equation, first factor everything. Find a common denominator. Again, best case scenario is you find the lowest common denominator. Hey, just let me pause for a sec, guys. Okay, sorry, I'm back. So find, I forget what I was saying, sorry. So find a common denominator. Again, the lowest common denominator is the best because then you won't have to just simplify it further, but it'll get you there, so don't worry. So simplify and isolate the variable. Remember, we must always check the solution with the restrictions or with the non-permissible values. If our solution is one of our non-permissible values, like it was in question 3 there, we have something called an extraneous answer. Super extra, Atlanta just said behind me. Oh, perfect. Yeah, just give me a couple seconds. Sorry. We should always verify our work by substituting our solutions into the original equation. And we can always check our work. I don't think it has that on yours because it's the same sentence as the previous sentence. All right, so just one quick thing. I'm not going to go over it, but I'll photocopy it for you guys. Question B in the practice. So just flip over to it. So it's 1 over x minus 1 over x plus 1 equals 1 over 6. If you use your lowest common denominator as x times x plus 1 times 6, what you're going to get through the whole simplification is you're actually going to get a trinomial. So you're going to end up with a quadratic. And what you need to do is factor that trinomial. So thinking back to, in this case, you'll factor by inspection. You could do decomposition as well, but you need to factor it and then figure out which values would make that equal to 0, because you would have collected everything on the same side. So you're going to have that x squared value, and that's a bit of a different situation. So in that case, when you look back at 1b, there's actually 2 values for x that would actually make it true. So you'd have to verify each of those values independently in order to make sure they both work, but they do actually both work. So peek at that. All right. Thanks, guys. Bye.